Starting with the blessed name of Allah, myself, Ahmed Walid, and along with my project mate Danish Tanveer, I am here to present my final year project design, fabrication, and characterization of ultra flexible temperature sensor using multi-walled carbon nanotubes for electrical applications under the supervision of Dr. Muhammad Waqas Sumro and Dr. Muhammad Afaq Manzoor Sumro from Sakhar IBA University. This is the contents of my slide. First of all, I will discuss introduction, then problem statement, literature review related to the project, then aims and objectives, design and development, result, practical implementation, achievements related to this project, conclusion, and in the end, video of the project. First of all, let's talk about the introduction. We know that flexible and soft electronic devices is growing day by day. Most of researchers are doing research in the field of flexible electronics and biomedical field. So other than high efficiency, these sensors also provide some other requirement like high stretchability, flexibility, and low power consumption and lightweight. So we took idea from this biomedical field and implemented and tried to implement this idea in the field of high power electrical appliances to measure their temperature. Now I will talk about the problem statement behind the making of this project. To monitor the temperature of different high power electrical appliances. We know that if an appliance is run for a long time on a height for overloading, its temperature increases. Due to excessive heat, it can burn and result in bursting. For example, in distribution transformer has a life of 25 to 30 years with proper maintenance. But due to overloading, its life decreases, hence temperature rises and can result in bursting. So this was the problem statement behind making our project in order to save all these appliances from bursting and burning. Before making this project, we did some literature review in order to analyze some of the existing materials and techniques used in the making of these flexible sensors and their limitations. Now I will talk about some aims and objectives. To sum up in one line, that is, this project is designed to monitor the temperature of high power electrical appliances I have discussed as I have discussed earlier. First of all, first objective is to make it flexible so that it can be placed at any point and it provides a greater stretchability. Second thing is material. We are using a novel composite material, multi-walled carbon nanotubes with the universal solvent dimethylformamide DMF and Ecoflex, which is a polymer. And third one is designing and development. Molding and casting will be used to develop sensor. We have developed our own molds in Fab Lab Sakhar IBA to design these sensors. The last one is detection. These sensors will be connected to an IoT device like ESP32 module in order to send the temperature remotely to a user. Now I will talk about the methodology behind the making and designing of this project. First of all is material selection. As I have told you earlier that after literature review, we came to know that we are going to use multi-walled carbon nanotube with dimethylformamide as a sensing layer, along with Ecoflex polymer, which will provide elasticity and stretchability, which is a polymer and will provide us higher flexibility. Second thing is characterization. After making selection of the material, we did some characterization by varying its thickness and composition to analyze which sample is good and is giving us results. Third one is implementation. We interfaced it with ESP32 module to send its reading to a user which is placed remotely. Last one is monitoring. We will monitor the temperature of an appliance through a mobile app which is developed through using Android Studio. This is the general block diagram of of my project. First of all, the sensor will be placed on an electrical appliance. Then there is a PCB design. This PCB design is used for ESP32 module will be stick onto it with voltage divider rule. The voltage divider rule will convert the resistance into voltages, and ESP32 module will send this data to the Firebase. From this Firebase, an Android app, mobile app, as it is shown here, will get to fetch data from this Firebase remotely, and so it will be showed to the user. These are the communication device ESP32 module. Here it is the ESP32 module in this on the left side, and on the right side it is placed on the PCB design PCB. This PCB, as I have already told you, consists of voltage divider rule in order to convert the resistance of the sensor to the voltage. This is the complete characterization setup of our project. This is the hot plate stirrer placed in our lab for characterization of the temperature sensor. This is the weight machine for measuring of multi-watt carbon nanotubes. This is multimeter or mobile app. This is the scale for measuring stretchability and flexibility of the sensor. This is the spray machine to spray the nanomaterials uniformly on the EcoFlex layer. This laptop for laptop is used to program to run program to the ESP32 module, and also to get data on Firebase. Now I will talk about some design and development. I will share complete designing, fabrication, and characterization setup. First of all, designing. As I told you, we designed all the molds by ourselves in FabLab Sakhar IBA. These are the molds. These are 10 centimeter long and 5 centimeter wide. This is the design of PCB. As I have already discussed, like this is the schematic diagram of the board, and this is the printed diagram, printed pictures of PCB design. This is the top view of the PCB design. This is the bottom view where ESP is placed, and this is the final product from side view. That as I have already shown you about this picture. These are the materials that we used in making our project. First of all, EcoFlex A and B, which are mixed in equal ratio. This is the dimethylformamide DMF, which is a universal solvent, and multi-watt carbon nanotubes. A measured value of carbon nanotubes is taken. Then some of the EcoFlex is taken in measured quantity. We mixed it properly, and then it is placed it is in the mold to make the first layer. These are the initial samples that we have prepared. This is the simple EcoFlex. Then we analyzed which electrodes are best for our project. We used copper tapes, and in some of them we used copper wires. Because after that we came to the point that copper wires are not suitable because they are not meeting our objective, which is flexibility. This sample is the multi-watt carbon nanotubes plus EcoFlex, but without DMF. But this sensor doesn't give proper results because EcoFlex is the polymer, and because of the bonding properties, it doesn't allow multi-watt carbon nanotubes to sense any kind of conductivity. This is the complete journey of sensor designing. We started from here and came to here, and in the next slide I will show you some more, go through some more journey related to this. So we made different sensors with different compositions, with different shapes, because this is the part of the characterization. we started from here and moved here, and in the end, it was our final sensor. I will show you in the next slide. These are the final sensors of our project that we are proposed. These all are of different compositions, different composition and different thickness. After once we have made a final product of our which is the ultra flexible temperature sensor, we did we calculated its electrical responses, like we get its result of resistance and temperature. As multi-wall carbon nanotubes is a semiconductor, so it is a negative temperature. It has a negative temperature coefficient. So with increase in temperature, its resistance decreases. We took 3 samples with different composition. First one is 7 mg, and then 14 milligram, and then 20 milligram. These 3 composition are proposed as a best composition so far. We came to know that this 20 mg design is close to linearity and giving us good results. And we took the same sample and also calculated its response and recovery time. First of all, at room temperature, its resistance was 0.55 kilo ohm. After it's based on a hot plate stirrer, which is taken to 90 degrees C, its resistance decreases simultaneously, as you can see in the graph. And after after some time, it was placed onto a table which is of 25 degrees centigrade, which is on the room temperature. As you can see, its resistance was going to its normal position gradually. After the making of the sensor, it was now the part to make some practical assembly of using SolidWorks. This is the assembling rod. We have made it in SolidWorks. This is the bottom sensor shield, which will hold our sensor. Then this is circuitry box. This circuitry box will contain ESP32 module with battery and PCB design. This is the complete assembly of the of our SolidWorks design. This bottom shield will be placed will stick to the machine. This adjusting rod will adjust this box, because if you can adjust it according to your need, because some machines are larger in width or length. You can adjust it according to your need. Now I will talk about app development. As our temperature sensor is sensing the temperature of our electrical appliances, so it was necessary to obtain its temperature remotely, because our user will never be close to the machine, so he will definitely need some mean to measure the temperature, to monitor the temperature of its machine. So from ESP32 module, the data is coming into the real-time database in Firebase. From this Firebase, the data is going to the our mobile app. Node 1, Node 2, Node 3, Node 4 represents ESP32 modules of different machines. Node 1 represents machine 1, Node 2 represent machine 2, Node 3 machine 3, and Node 4 appliance or machine number 4. Now I will show you a video of practical implementation. First of all, in first picture, as it is shown in we placed it on the synchronous motor placed in our lab. As you can see here, this is that sensor placed on the motor, because it is measuring its outside temperature and sending its temperature to our app. Secondly, we implemented it on residential water pump and measured its temperature. Thirdly, we implemented it on hydropower plant, turbine generator plant placed in our lab in Sakkar IBA University. And fourth one, we placed it on solar PV module placed on the rooftop of our Sakkar IBA University. And lastly, we placed it on Marset boiler, which is placed in the thermodynamics lab of Sakkara University. Now I will talk about some achievements related to this project. We took this idea into Microsoft HEC Imagine Cup 2022 and was named as a second runner-up in South region from Sakkara University and won the prize of 25,000 rupees. Secondly, we applied this idea into the Ignite Clean Tech Innovation Challenge 2022 and got shortlisted. Now let's talk about the conclusion, what I have done through this project. First of all, we have designed, fabricated and characterized a flexible sensor in our lab. We used copper tape as electrodes. We used a spray coating technique in order to spray uniformly multi-wall carbon nanotubes on the EcoFlex layer. Last one is sensors, electrical, mechanical, and chemical properties were completed to evaluate the properties. Electrical responses include the response of decreasing resistance with increasing in the temperature. Mechanical properties were analyzed by stretching and flexible stretching, bending, and twisting. Chemical properties of multi-wall carbon nanotubes and dimethyl formamide and EcoFlex material were also analyzed. This is the complete progress video what we have done through this project from start to the end. These are the materials we have used. These are the mold that we placed. This is the composition of EcoFlex. First sample of EcoFlex. We are pouring material on the EcoFlex layer. Now spray coating process of multi-wall carbon nanotube. Here you can see we are spreading multi-wall carbon nanotubes through spray coating machine on the layer of EcoFlex. Second half core process of EcoFlex material. These all take 4 hours in order to completely dry. First layer 4 hours, second layer also take 4 hours, and whole process takes almost. If you have any questions, you can ask any question in the comment section, and you can also contact us via our email and mobile numbers that are shown on the screen. Thank you for watching, and Allah Hafiz.